In this video, we're going to look at the first order ODE called the Bernoulli equation. Okay, so the differential equation of the form dy dx plus y p of x equal to y to the power n q of x. Let's call it equation 1, where p and q are functions of x only, and n is a real number. So this equation is called Bernoulli's equation. It's called Bernoulli equation. The cases where n is 0, okay, so if n is 0 here, so this side is just q, or when n is 1, so this time n is 1 here, then this is going to be like term to that, so can we just combine them to give one term. So the case is n is 1 and n is 0, such that the ODE reduces to linear, reduces to become a linear ODE, to a linear ODE. Okay, and then for the cases where n is different from 0 or 1, this theorem is going to help us to deal with that. So theorem, so the theorem goes, the substitution. So we're going to introduce a new variable v, and v is going to be y of x to the power 1 minus n. So the substitution v is y to the power 1 minus n, transforms the Bernoulli equation 1 into a linear equation, Okay, so let's see how this works out. So proof, okay, so we're going to start off with so starting with I'm going to use the prime notation now. So y prime plus y p of x is equal to y to the power n q of x. Okay, if we divide everything by y to the power n here, then we're going to have y to the power negative n y prime here plus y to the power 1 minus n p of x is equal to q of x. Now then from v equal to 1 y to the power 1 minus n, if we differentiate both sides with respect to n here, then v prime is going to be 1 minus n, and then we subtract 1 here, and then times y prime. From this we can see that y to the power negative n y prime is v prime over 1 minus n. So what we're going to do is we're going to substitute. Notice that this term is exactly the same term as this one. So that's going to be v prime over 1 minus n. And this term is the same as that one. So that one is going to be v. Okay. So let's call this equation 3. So substituting into 3 gives, so 3 is now going to become v prime over 1 minus n plus v times p of x is equal to q of x. And then if we multiply through by 1 minus n, v 1 minus n q, then that gives us an equation which is linear in v, which is linear in v. And so this can be integrated using the methods we've established under the linear ODEs section or video. So let's look at 2 examples. For examples here, solve. In A, going to have y prime minus 2xy is equal to 2x cubed y squared. In B, y prime minus y is equals to x square root y. Okay, so in the first example, we can see that this is not going to be linear because of this term here. So, but it fits the Bernoulli standard equation where n is equal to 2. What we're going to do is similar to what we did here, where we divided by this term. So I'm going to do the same thing here. I'm going to first divide everything by y squared. Okay, so dividing by y squared gives, so we're going to have y to the minus 2y prime minus 2x y to the power negative 1 is equal to 2x cubed. Okay, then we're going to let this thing be v. Okay, so let v be y to the negative 1. So it's exactly the same as what we did here. So once we divide, then we'll let this become v here. And then we work out v prime and substitute, and then that's that. So v prime is going to be negative y to the minus 2 y prime. This means y to the minus 2y prime is negative v, the ODE becomes negative v prime minus 2x v, y to the minus 1 is v, is equal to 2x cubed. Okay, so v prime plus 2xv is negative 2x cubed. This is now linear, okay? And the integrating factor is going to be the exponential of the integral of 2x. So mu is the exponential of the integral of 2x. So this is just e to the x squared. So if we multiply the ODE, so multiplying ODE gives, so remember this is just going to be d dx of v times e to the x squared. And then on the left hand side, we're going to have negative 2x cubed e to the x squared. So the left hand side just integrates to v e to the x squared. The right hand side, we have got negative integral of 2x cubed ex squared dx. So we're going to take a bit of time to work this out. Well, this integral, if we regroup the terms like this, so x squared e to the x squared there, and then 2x dx here, okay, then we're going to use the method of u substitution. So let xi be x squared dxi is going to be 2x dx. So that means this is just dxi, that is xi, and that is xi. So that means our integral x squared e to the x squared 2x dx is going to be equal to xi e to the xi dxi. And then this we can integrate using parts or tabular integration. Let's do it here. So xi derivative of xi is 1, derivative of 1 is 0. These ones are all going to be equal. The first one is always a plus. So that means this thing is going to be xi minus 1e to the power xi plus k. But then xi is x squared. Okay, so we're going to substitute back. So thus we have got v e to the x squared equal negative x squared minus 1 e to the x squared plus a constant. Okay, and then v is going to be 1 minus x squared plus k e to the minus x squared. But then remember, v is y to the power negative 1. So there is v. So this is equal to 1 over y. So that tells us that y is 1 over everything here, 1 minus x squared plus ke to the negative x squared. So that's going to be our general solution there. All right, so now we're going to go back. We're going to ask you to have a go at example number B. Just pause the video, and then when you're done, press play, and then you can compare your answer to our answer. All right, we're now going to scroll down to our solution for part B. So for this one, first thing we're going to do is to divide through by square root y, which gives us this equation here. And then we're going to let this term be v, so that its derivative is y prime over 2 root y. When we take the 2 to this side, it means this term is going to be 2v prime. This term is v, and that's just x. We need this to have coefficient 1, so dividing through by half, then that is going to tell us that our integrating factor is e to the x on minus x on 2. So then if we multiply this by this here, which is going to get v times the integrating factor, derivative of that, and then this side we're going to get x on 2 e to the minus x on 2. So if we integrate this side, we'll get just what is inside the square brackets, this one, integral of that, which we integrate using tabular integration here. So x on 2 we differentiate to 0, e to the minus 2 we integrate repeatedly, and then we match them like that. So that means we're going to have v e to the minus x on 2. This is negative x, and that is negative 2. And then bringing this to the other side, we have got v, but v is square root y. So from there we can make y the subject of the formula. So that is our final solution. Okay, thanks for watching the video. Hopefully you find it useful. If you do, please do subscribe so that you can get notified whenever we post new stuff. Thank you.